And we're just going to find the vertical asymptotes, horizontal asymptotes, and graph the function on Desmos. We're not going to graph it by hand. So vertical, denominator equal to 0. Example 5. If you need to factor it, factor it. I got x plus 5, x minus 3 equal to 0. I should see an asymptote at negative 5 and positive 3. Okay. Go ahead and find the horizontal asymptote now. So for the horizontal, you're going to look at the ratio of the leading coefficients. Why? Because the top has an x squared and the bottom has an x squared. That's considered to be balanced. So your horizontal asymptote should be at 4 over 1 because of the 4 over 1, 4. I'm going to pause the video if you're watching at home, and we're going to put this in Desmos. Okay, I started the recording again, and we're going to check these out on Desmos when we're done doing both of them. Let's go ahead and do the try it now. If you already got started, great. I'm going to go over the answers here. The vertical asymptotes will be found by setting the denominator equal to 0. If there's no x in a quadratic, you can solve it by getting x by itself. Add 10 to both sides. Divide both sides by 2. Square root both sides. You get plus or minus root 5. For horizontal, you're looking here at the leading coefficients. If there's an x squared on top and an x squared on the bottom, 1/2 is where the asymptote will be. 1/2. So these are the verticals. This is the horizontal. And we have both of those problems complete. Now, over here on Desmos, you'll see example 5. I have this equation loaded in here. And there it is. We thought there would be a vertical asymptote at negative 5. There it is in purple. We thought there would be a vertical at 3. And there's a horizontal at 4. And look, as we go really far to the right, it gets closer and closer to that line. And as you go really far to the left, it gets closer and closer to that line as well. So that's what it means to be asymptotes. The horizontal is the line that it's approaching in the long run as x gets really, really big or really, really negative. And the vertical lines are the ones where the graph, where it can't equal 0. Because if the denominator did equal 0, the function would be undefined. Okay, so where's that leave us? Well, we have example 5 done. So your homework, let me stop the video. Ignore this if you're watching on video.